Thank you again, everyone, for joining this morning. This is the introduction to the Linux shell using the command line. So I've pasted a link into the chat, which is a link to a web page for a GitHub repository, where I posted a couple files that I'm going to be talking about this morning. We won't necessarily be editing any of these files, but we'll be using them in the course of interacting with the command line. If you'd like to follow along with what I'm talking about, go to this link and then scroll down to the two links at the bottom. For those of you who are UCLA participants, you're welcome to click on the first one. This will launch you into a Jupyter Hub, which is where we'll be able to access the common Linux environment for all of us to interact with. There's also the option to launch Binder, which is a separate service, which will essentially launch you into a very similar environment as what I'll be showing with the Jupyter Hub. Once you launch into Jupyter Hub, it will require you to do to authenticate. You can either choose Google or UCLA. If you choose Google, you'll have to use your g.ucla.edu email address in order to authenticate. Or you'll do the two-factor authentication with UCLA. But once you launch into that, it should land you on a page that looks like this. So I'm going to come back to this. In the course of logging in, certainly let me know if anybody has any trouble logging in the chat. But for the moment, I'm just going to be doing some talking. So I'll come back to make sure that everybody has logged in just a bit. What we're looking at here, just to orient you, is the browser interface for the Jupyter Hub that you're going to be interacting with. So it's actually launching you into a containerized environment on a web server, which is sitting on computers that are hosted on Google Cloud, actually. But you can think of this as like it's launching you into your own Linux computer. We'll talk about how to interact with the terminal in just a bit, but what you're going to see here on the left is like a file menu. So these are the files that we're going to be able to interact with. Up at the top, this is going to show us our path for the particular directories that we're going to be interacting with. And on the right, I'm showing a rendered version of this file called presentedmaterial.ipynb. This is a Jupyter notebook. You don't have to worry about anything about how I set this up. This is more just to be able to show you material like images and text that will be useful during the course of our class. So something like this, in the course of introducing you to this interface, I'm already starting to talk about files, file paths, looking at files, and this itself is a graphical user interface to interacting with the Jupyter Hub. In the course of interacting with your computers, some of you might be much more familiar with Windows or with the Mac operating system. This is a picture of the Windows 10 interface. Very highly developed graphical user interface where you have a start menu. You can come here and select on different programs or applications and launch them. And then you have the option of opening up Windows where you can navigate to different files on your computer. Something similar has been developed for Mac, the Mac operating system. This shows a bunch of shortcuts, applications that you can launch. And as well, it's showing here a file window where you can interact with folders and with files that are on your computer. The basic idea is that you navigate just by moving your mouse around this interface and clicking on what it is that you're interested in, or you double click, say, to open files or to launch applications. So really, you use your mouse and the keyboard as well to type into the interface, but a lot of this is set up graphically, and it's intended to be relatively user-friendly. This third one that I'm showing is an interface for Linux. So there are graphical user interfaces for Linux as well. I don't remember whether this is GNOME or KDE, but those are two examples of graphical user interfaces for Linux. But then, aside from interacting with your computer through a graphical user interface, you can also interact with your computer through a command line interface. And the command line interface is much more spare. You know, you don't have lots of pretty icons, and you don't really interact with it by moving your mouse around the window. You're presented with a text prompt where you enter text and then hit the enter key, and then that issues commands to your computer as far as what you want it to do. Conceptually, in a very abstract sense, the graphical user interface and the command line interface are very similar things, in that they allow you as the user to interface with your computer and to tell the computer what it is that you want to do. But in terms of practical use of this, interacting with the command line interface is much different than interacting with the graphical user interface. And when we interact with the command line interface, what we're actually doing is interacting with the shell. So that's in the name for this course, Introduction to the Linux Shell. So there's the question, what is the shell? This is a very abstract concept of what it is that you're interacting with when you're interacting with a computer that has Linux on it. So a shell is a program that takes your human readable commands and gives them to the operating system to perform. At the very base level of your computer, you have the computer hardware. So this is like where you have the CPU, the RAM, you know, the various devices that are attached to your computer. On top of the hardware, you have the kernel. And you can kind of think of this as like the operating system. So there's the Linux kernel. The kernel I've written down here manages stuff like, it does file management, process management, which are like your applications that are running. It has input and output management. It manages your memory. It manages all the devices that are connected to the computer. The kernel itself is computer software, and it's a program that really lies at the heart of the computer's operating system. Surrounding this is this shell of a thing, which is called the shell. And the shell is what you can use to give commands to the operating system. And then on top of this, you have your applications and users, usually interface, say, through a graphical user interface, through these applications. Or if you're accessing the shell through a terminal, you can use the terminal to interface with the shell and to issue commands to the computer. So these are a couple pictures of very old terminals. You know, a lot of this computer lingo kind of derives the names from concepts which were, you know, in the process of being developed when computers were developed. And initially you had to interface with, say, these computers, which were these gargantuan things, through some kind of device like this. So these are just kind of amusing. I think two of these are IBM, and I forget what the other one is, but these are examples of old terminals, say, that you could type on, and that would then execute, issue the commands to the operating system and to the computer. Fortunately, we have a little more flexibility now in how we give commands to our computer. But conceptually, it's very similar. So the terminal is something which allows us to interact with the shell. And the terminal allows us to type the commands. And when we type the commands, the shell then takes those commands and gives them to the computer to to execute. And as our final bit of setup, why is it interesting to use the command line interface and give text commands to the shell rather than simply using the graphical user interface? So the graphical user interface is something that's it's designed to be very user-friendly. And in fact, it is much more user-friendly than the command line interface. Even though I'm familiar with interacting with the command line interface a lot, I still use a graphical user interface a lot just because it's so easy. But on the other hand, the command line interface does have some advantages. So it has a lot of power. With just a couple commands, you can really do a lot of things with your computer. And once you get very proficient at doing this, you can do them very efficiently and much faster with the command line interface than you could with the graphical user interface. There's also a lot of flexibility that comes with the command line interface. So you're limited in the graphical user interface to the options or the menus that you can access. So say you have two folders open and you want to copy a file between two folders. You can open up the two folders on your desktop, and you can click on the file you want to move and drag it between the two folders. You can do this for multiple files. You can select multiple files at once from one folder and move them into another folder. But say that you decide that you want to move only those files from one folder that have been modified, say between 2018 and 2020. Only files that have been modified during that time, you want to move them to a different folder. So you kind of have to fiddle around a little bit to get the modification times on the files and figure out what to drag, and then you'll be able to drag them maybe one by one. Maybe you'd be able to select some if you sorted them by the date. With the command line interface, you can make things like this much more rapid, because it really gives you access to a lot of the information that is accessible when you're accessing the entire file system that's stored on the computer. Another advantage of using the command line interface is that you really have support for automating repetitive tasks. So if there are things that you want to do over and over, you can, say, write a script, which you can just execute with one command, and then it will carry out the entire task for you. Another thing that you can do is you can schedule tasks yourself, so that if you want to do something at 8 a.m. every day on your computer, you can set up the task yourself. And then finally, sometimes it's just necessary. Like for those of you who want to do computing on Huffman 2, say you'll SSH into one of the login nodes on the computer cluster, and there you're just going to be directly interacting with the Linux operating system, and you have to know how to use the command line interface to interact with the system. So it definitely has advantages as far as the capacity to access network machines and to interact with those machines. And of course, there are some disadvantages which kind of go in tandem with the advantages that I was talking about with the graphical user interface. So the command line interface is primarily textual in nature. So you just type in text to execute the commands. And it can be cryptic. So, it's almost like you're incanting spells to the computer, and through some kind of magic that happens in the computer, these commands you've typed in then get turned into things that happen in the hardware. So there's a certain amount of learning and experience that has to go into being able to become proficient with the command line interface. But it's definitely not undoable, and it doesn't take a lot of time actually to learn the basic commands, which will get you far in interacting with this interface. So let's dive in and try to execute some commands. So let me come back to, I'll just paste in the chat window again the link here if anybody has joined after I started. Once you go to this link again, you can launch into the Jupyter Hub, which will launch you into an environment like this. By coming down to this first link and clicking on it and authenticating onto the hub, or you can launch into Binder with this one, which will launch you into a similar environment. And what I'm going to do now, actually, for those of you who are following along, is I'm going to launch a terminal. So through the process of interacting with the hub through this web browser-based interface, we're interacting with a Linux operating system. And if I come up here to plus and click on plus, it will open up this new window. And down at the bottom, if you scroll to the bottom, is something called the terminal. And to open that, I just click on it. That will open up this terminal. I'm going to pause here and ask if anybody's having any difficulty accessing this. Yes, feel free to unmute yourself and ask a question or type it into the chat.
Oh, mine is working if I launch it through Binder, but I guess the UCLA login just brings me to my login homepage, like accounts. I don't know, is that because I haven't used the Jupyter through the UCLA login before? Or I don't know, maybe I'm the only one who's having that problem.
I think for the moment, I would just recommend that you use Binder, and then we can figure out the issue with the Jupyter Hub once the class is finished.
Sounds good.
Do you still see these files presented on Binder?
In the launch. Mm-hmm. Yes, yeah, I do.
Does. Okay,
Thanks.
good. Yeah. One note for those of you who are using Binder, I think when I was testing this out last night, it didn't give you this first folder called IDRI Intro to Shell CLI. So you might have to make some accommodations if I start moving around between directories. The directory that the files are on, when you go into the Jupyter Hub, is in this folder, and if you're on Binder, it might just be in your home folder. So this just shows this / without the name. This might be a little more clear when we start going through things. One advantage to this Jupyter Lab interface that we're working with is that we can have multiple of these windows open at once. So come back to the presented material one, click on the name of it and hold the mouse down and then drag it to the bottom. So that this entire, see if I drag it to different sides, it has different ways to partition. Drag it down to the bottom one, and then release the mouse button, and you should have then the terminal on the top and the notebook on the bottom. All right. So I think we're set up now. I'll come back up to the terminal and click in the window. So now this cursor is blinking. So now we're at the command prompt. There are a couple of things to note here. One is that we'll have this kind of bizarre name, Jovian. And then we have an @ symbol. And then we have this long thing. There's the colon, the tilde, and the $. So the $sign tells you that you're at the command line interface prompt. When you interact with other operating systems, other shells, say on other computers besides this one that I'm making available on the Jupyter Hub, you'll still see this $sign, although this information here will be different. So this $sign tells you that you're at the prompt. This blinking cursor is where I can type in text. So if I type in text, it gets put here on the line where the cursor is blinking. This tilde will come to shortly when we talk about directories, but this is the name of the directory that we're in. This first part, Jovian, is your username on the operating system. This name will be different for you. This is my username when logging into the Jupyter Hub. So your username is based around your email address. I'm not sure actually what it will show if you're accessing this through Binder. But this, for example, is my kind of a re-rendering to make my username more friendly for the system of my email address, which is bwinjim@g.ucla.edu. So just to dive in and execute some commands, let's look at the date. You can just type date, hit enter, and it will give you the date. So that was easy enough. This is one of the built-in commands that the shell has, and it tells you what the current date is. It's Friday at 4:26 in UTC time. This is not Pacific Central Time, Pacific Standard Time. So it's like at 7 hours ahead. So this tells us that it's 9:26. I can execute date again by typing just date and hitting the enter button again, and you'll see the date now is something different. Something else which is useful to know to get a little more proficient at this, if you type the up and down keys, the up keys will go to previous commands that you have executed when interacting with the shell. So at the moment, we haven't done much. Typing the up key might not give you much more than date. If I type the up key, it will give me date. If I type down, it just takes me back to waiting for the command to enter. So I'll come back periodically to this once we have more commands that we've entered. The other thing is tab completion. So if you start to type a command, say, but you don't want to finish typing it, say you're too lazy to even type 4 characters, I can type the first characters and then hit the tab key. So I've hit it twice actually. The first time, what it's going to be doing is it's going to be looking for files that are inside of the folder. If I hit it twice, it's going to give me, it's going to tell me what it thinks is reasonable to complete the command that I'm typing in. So I've typed in DNA, and when I hit tab twice, it spits this out and then asks me to complete the command. So these are actually all of the commands that I could type in to finish what command I'm typing into the shell. So data is the one I want. If I type DAT and execute the tab key, then it gives me date. So I might be using tab completion absent-mindedly throughout this, just because that's a common thing for me to do. But if I type any commands and all of a sudden you see that the entire thing is filled in, it might be because I'm using the tab key, and the tab key tries to autocomplete what it is that I'm typing in. That's a little bit of setup. The only command that we've executed at the moment is date. So date prints the date. I have another one here, who am I? If you type in who am I, this will tell you your username on the system. All of you should see Jovian actually, because when you access this Jupyter Hub, you're effectively all being logged into your own individual operating system. I won't talk about what containerization is, but the Jupyter Hub launches one container for everybody who's logged in, and they're separate from each other. So you all have separate file systems, and you're all logged in as this user called Jovian. If you were to log into another computer system, say where you logged in with a specific username and password, this will give you your username on the system. And then just to type a couple more, df will show you the disk usage on the system. This tells you various things about the system, which I won't get into, but over here you can see the percent utilization of these particular devices that are mounted. And free will tell you the amount of free memory that's on the particular system that you're accessing. These numbers up here are in bytes. These down here are also in bytes. There are ways to make them more human readable. But for the moment, this is just introducing us to executing commands. So the basic idea is we type some command. You kind of have to know what command it is you're typing first. And then we hit enter, and then this then gets sent to the shell, and the shell figures out how to use this command then to tell the computer what to do, and the computer does something and then returns output back to us. And that output gets printed here on the terminal screen, the same screen where we're entering the commands. So there are names for these things. There's standard input. The standard input right now is we're using the keyboard for standard input to type commands onto the command line. And when I type this then there's also standard output, and there's standard error. We'll come back to those in a little bit, but all you have to worry about right now is that standard output and standard error are going to both be what's printed here after we execute the command. So output is just kind of regular output. Standard errors, but very specific for any error messages that the shell encounters when executing the commands. So say I type FRE rather than FREE, and I execute this. Now that there's something sent to standard error because there's an error message. The error message comes from the shell. Right now we're interacting with the bash shell. So there are a couple of different varieties of Linux shells that we can interact with. The first Unix shell was called SH. Bash comes from the Born Again shell, and Born is the name of somebody who developed the shell. You might also see the Z shell or the C shell. Right now we're interacting with Bash. And then it tells us what it's complaining about, which is the fact that we only typed FRE. And then it tells us why it's complaining. It tells us the command was not found. And so in this case, it would be clear to us, why this is returning an error. It's just that there is no such command. If I type the up key, I can get back to that command, and I can type the E again. And when I hit enter, then it just prints the standard output again. And then finally, kind of one useful command that's you're going to be using over and over is just how do you get out of this? So I've gotten into it just by clicking on the plus button here to open up the terminal application. I can quit this particular terminal instance by typing exit. And when I type exit, then that just gets rid of the terminal. All right. Are there any questions at the moment about anything I talked about? Okay, good. So now I'll talk about something a little more concrete, files and directories. When you're interacting with Linux, you're interacting with a whole tree of files and directories, as it's called. So I'm going to talk a little bit very briefly about the file tree. So here's a picture of an actual tree. This is a tree that I think is really pretty, and I'd like to have in my yard for a drought-tolerant landscape. But the basic idea is it has a trunk. It has it's rooted to the ground. It has a bunch of branches that come up here, and as you start getting higher, you get a lot more branches, and then you get leaves that are coming off of it. In essence, you can kind of think of the branches like your directories, and the leaves that are coming off of it like the files that are kind of attached to all of these branches or directories. So if we think about the Windows tree, when you look at your folder manager, I forget what Windows calls it, but what you look at the, when you open up a window that shows you various files and folders that you have. Your computer, is the root of the tree, which kind of supports the entire operating system. And then the various branches that you have coming off of here are like the different folders that you have. And for any given folder, you can have folders within that folder. So you can have branches coming off of the main branches. You can have folders within folders, and then you can have files that are inside of each of these folders, like little leaves that are coming off of the tree. Linux is set up very similarly. So you have what's called the root directory. And then out of this root inside of this root directory, you have other directories. And inside of those directories, you have other directories. So it's a whole hierarchy of file system directories. One difference between the Windows tree and the Linux tree is that with Windows, if you've interacted with Windows, you might know, like if you attach a CD drive to this, or if you insert some kind of flash drive into it, it won't be referenced as the C drive. It might be the D drive or the F drive. There are different roots here which come in when you attach devices to Windows. As far as Linux is concerned, everything is attached to root. There is no separate drive that gets set up when you attach different devices to it. So instead, you mount those devices into the existing file system tree. And that's kind of why it's called mounting. You actually have to attach these devices in a way that's acceptable to Linux to interact with. As we start getting closer to the command line interface, this is a picture of the graphical user interface of that file hierarchy. This is from Windows, so it has the C drive. But there's this whole hierarchy of folders that you open up. There are folders within folders, kind of gets dropped down. So this tree ends up evolving sideways here, or kind of in the down direction from top to bottom. And then within any folder, you can have other folders and you can have files. If we look up at the top, we see the path of the particular folder that we're in. So we're in this folder called fuzzy sets. We can see the folders within it here, as well as the files that are in it here. But then you can see the path back up to the root, or in this case, to the base C folder. There's fuzzy sets, my maple, my documents, and then it kind of gets a little fuzzier here because it doesn't show you the username or the documents and settings. But the idea is the same when you go to Linux. So the root is represented by the slash. And by the way, this forward slash is in a different direction than what's on Windows, which is the backslash. So you have this slash, which represents the root. And then inside of the root directory, you have any number of other directories. Inside of those directories, you have other directories. And then you kind of, branch out with the tree growing upside down in this direction. The reason it's written this way is that you have parent and child directories, is how they're referred to. So this say is a JSON directory. The parent directory to JSON is the one that gets it closer to home, or I'm sorry, closer to root. You can think of this as like a little tree trunk. So here's our root directory. The parent directory to JSON is home, and the parent directory to home is root, which is just represented by the slash. And anytime that you're considering paths inside of this file system, directory names, if they start from root, then the path always starts with the slash. And then folders are separated by another slash. Just like here, when you look on Windows, the different folders are separated by the slash here as well. So now let's go back to our terminal. So I'm going to click on the plus sign again and open up the terminal. And I'm going to drag this to the bottom so you can see both screens at the same time. So the first fundamental command that I'll mention here is pwd. Pwd stands for print working directory. And what this does is it prints the file path of the directory that we're currently in. This is the directory that we're currently in, /home/Jovian. Slash by itself tells us that we're starting at the root directory. Inside of root, we have home. And then inside of the home directory, there's another directory called Jovian. And we know it's a separate directory from home because it's separated by the slash. Jovian is our username. So when you log into the Linux file system or access the terminal, the first directory that you end up in is called your home directory. And your home directory is where you make your files, save all your folders, and kind of do all the things that are associated with you as a particular user on the system. There are a lot of other folders that you can access here besides just your home directory. I have ls here. Ls will list the contents of whatever directory it is that you're currently in, your working directory. So if I type ls, what you'll see actually is, you might not see this missed because I'm on a different system than you are, but you should see this one. Or, well, actually, if you're in Binder, just as an aside, you'll see the files that you have. But if you're accessing this through Jupyter Hub, you'll see the particular file, or I'm sorry, the particular folder that we've cloned into this environment. And then we can change the directory that we're interacting with the cd command for change directory. And so to change directory, you type cd and put a space, and then you put the name of the directory it is that you want to change into. So I'm going to change directory into this one. If I type IDRE and simply hit the tab key, this will do the tab completion. So, I might not want to type all that in. Might be easy to make a mistake. So I just type the first couple letters, hit the tab key, and it completes it for me. And then when I hit enter, now you'll see that the prompt has changed. This is telling me that now my working directory is different. This here is telling me what my working directory is. The slash is just an abbreviation for your home directory. So say I want to change into my home directory. I could do cd space and then this tilde. The tilde on my keyboard is kind of a character that's up beside the letter of the number keys, and I have to type shift to enter it. So if I do cd space tilde, the little squiggly line, and hit enter, it will take me back to my home directory. And I can figure out it's my home directory by typing pwd again. Pwd will print my working directory. This is my home directory. And then I'll type the up keys just to remind you about those. I can type the up keys to get back to this particular command here. right, you can kind of see here, I have pwd ls cd into this directory, cd into home, pwd in this again. So if I type the up and down keys, it cycles between those different commands that I've typed. So then this is just another shortcut to get back to this if I don't want to type it. Because in the name of efficiency, we're trying to, we're using laziness to our own advantage. So I'll change directories back into IDRI intro to shell CLI. And then I'll list the contents of this with ls. Now when I type ls, it tells me the particular files that are in my working directory, as well as any other directories that are in it. You won't necessarily be able to tell from this whether something is the file or whether it's a directory. And actually, as far as the Linux file system is concerned, even file directories are files. So the Linux operating system approaches everything as a file, even the entire file system hierarchy. But that's an aside for the moment. I've talked about the path. There are two ways to represent the path on your system. That's called the absolute path and the relative path. So the absolute path is something that's written all the way starting at the root directory. So starting with a slash. So if this directory existed on my system, it would be starting at the root directory. I would have the home directory, the Jovian directory, shell course directory, and basic dir as the directory name. When I type pwd, this gives me the absolute path for my working directory. So it starts with a slash. You might notice when I typed cd to change directories, I didn't have to put in the absolute path. All I did was I typed the name of the directory that I wanted to navigate into. And what this does is it assumes that the directory I've typed in is in my current working directory. If that's not the case, then it will give me an error. So if I type, or I'll use the up key again. If I try and type that command again, it's going to give me an error message because it doesn't recognize that there is such a file or a directory. When I type a path like this is called the relative path. And right now, this relative path doesn't exist in the directory that I'm in. This relative path only exists when I'm in my home directory. So I'm going to change back to home. And now when I type this, it would change directories into that. You can also use the arrow keys, by the way, to go forward and backward within the text to modify a command. So if I type, instead of using a relative path, if I use the absolute path, starting from the root directory, this will have the same effect in my current working directory. It will navigate me into this. And I can also execute this command once again, even when I'm inside of this. So just to remind you, I can't execute this because there's no subfolder of this one, which is IDRI intro to shell CLI. But I can type in, maybe, let's see, this one. I'm gonna make my screen just a little smaller. Although, let me know if any of you are having trouble seeing this. So that in this case, I say change directory into this, which is the absolute path. And I can execute this again, even though I'm already inside of this directory, because I'm giving it the absolute path. So it knows it doesn't have to refer to anything else before it can change directory into this one. So there's no conflict with this not existing. I've mentioned tilde as your home directory. And then two other abbreviations that I should mention are period and double period. Period is the name of is kind of a shortcut for your working directory. The double period refers to your working directory's parent directory. So just to remind you, if I type pwd, pwd prints the working directory. Right now I'm inside of the IDRI Intro to Shell folder. If I say ls, and then I can give it the name of the directory whose contents I want to list. Actually, it's kind of coming off the side of the screen here. Let me just see if I can trick it. Okay, here we go. So I mentioned list to give you the contents. You can also list a specific directory whose contents you want to list after the ls command. So if I do ls and period, this does the same thing as ls, because period is the shortcut for the working directory. If I do two periods, it's going to list the contents for my current directory's parent directory, which in this case is my home directory. So if I execute that command, it's going to do it's going to show me what list showed me when I was just in my home directory, which is the name of the folder. And in my case, miss, although you might not see this yourself. This shortcut can be used in any command relative to the file system. So say I want to change to, I want to go up to my parent directory. I can type cd and then the double period. That will shift me up now to my parent directory relative to the one that I was in. Or I can type cd and period. Cd and period won't do anything because it just shifts me to the directory that I'm already inside of. Even inside of my home directory, I can change up to the parent directory. So now my path is not my home directory. I've changed directory up to the parent directory, and now I'm inside of just home itself. So when I type ls, this will show me the folders of, in this case, it's a user, and there's another folder here called Shiny, which if you're familiar with R, the system is set up to use Shiny. So let's see, I've talked about list. I've talked about listing the contents of a specific directory by putting the directory after list. So let's list the root directory, which is this ls and slash. These are all the directories that are inside of the root directory. So the Linux system is designed to be relatively open. You can look at, anything that's on the file system. We might talk about permissions at the very end if we have time, but you can certainly look around at, many different things that exist in the operating system just by changing directory, listing the contents, and then investigating the files that you find. You can also list the contents of several directories. So say I do ls and tilde, which is the home directory, and then say I want to look at this user directory. So I reference the path for that. This starts from the root directory, and this usr directory is inside of the root directory. So when I execute that now, list accepts multiple arguments when you're executing it. So this tells me the contents of my home directory. This one tells me it's listing the contents of the user directory, and these are the directories inside of the user. And then just to wrap up a little bit before we'll get to an exercise here. You can pass in options to commands that you have. So an option is usually specified with a dash, and then typically one letter, although you can give entire words as options to commands. If I type ls and a, at the moment, this might not make a whole lot of sense, but it will list all of the files. So there are some files that can be in your directory which are hidden. Let's change back to the home directory and do listen all. If you do listen all inside of your home directory, you're going to see a lot of these files which start with a period. The files that start with a period are hidden files, which means that they aren't normally shown when you do something like list. A lot of these are text files or configuration directories, which are just intended to set up the configuration for your environment, or to execute, say, certain commands when you log into the system. There are various things that are here which you don't necessarily have to worry about interacting with when you're just interacting with your user files, but you might have to worry about them if you're worried about the configuration of your system or of your environment. So the listen-a will list all of the hidden files in addition to your regular files. And then list and -l will give you more verbose listings of the particular files that are here. I'm going to leave it at that for the moment because I'll talk about this after the exercise. But so just to take a breather and let you try something on your own. Let's say that we're here starting from a theoretical directory named home Jovian data. Which of the following commands that are listed below could you use to navigate to your home directory, which on this system is home Jovian? So take a minute or two to think about this and think about which one would take you to your home directory. And then since it's close to 10 o'clock, let's just take a couple minute break as well. So let's come back in 5 minutes at 10:02, and then I'll talk about the answers. Okay, I'll start up again here. So just to review, we're starting from a directory named home Jovian data, and we're trying to navigate back to the home directory, home Jovian. So this first command, cd and the period, would just change directories into the current directory, which in this case is data. So that won't work to change us to home. cd / will change us into the root directory, so that won't work. cd users Jovian might work if we're on a Mac operating system where the home directories are prefaced with users. But here the home directory is named with home, so this directory as just doesn't exist, and we will get an error message. cd period / period. This will change us into the parent directory, and then again into the parent directory of that parent directory. So that will get us all the way into /home, not into /home/Jovian. cd with a / would change us into the home directory. I've mentioned that / is the abbreviation for home. So that one would work. cd space home would try and change us into a directory called home within the data directory if it existed, which in this case doesn't make any sense, so that wouldn't work. cd tilde data period will work, although it's a little convoluted. So the cd into tilde would change directories in the home directory and the data directory, which changes us into this directory. And then following that into period, which is the parent directory of data, which is the home directory. So this one would work. cd by itself, I realized here I haven't told you that particular shortcut. So that will actually also work. Let me change into IDRI enter the shell. cd just by itself, if you don't give it a directory, will change into your home directory. So this one will work. And cd period will change into the parent directory of your working directory. So changing into the parent of data will get you back to home as well. So let's see, are there any questions about this before I move on? Okay. Now let me talk just a little bit about what I saw with ls-l. So with the commands that you come across in Linux, this is a kind of very typical format for them. First, you'll have a simple word, which is the command, the name of the command. Then you'll have options, and then you'll have arguments to that command. So the options are prefixed with a dash. Options can be prefixed with a dash plus a single letter, but they can be in something called long format. So you can have 2 dashes plus a full word. That's another way you'll see options. And you can have multiple options listed together at the same time. So I mentioned ls-a. So I'm going to change into this particular directory that's shown here, which is IDRI enter the shell. For those of you who are on Binder, you can just stay in your home directory. If I do ls-a, this shows me all of the files, including the hidden files. So now you'll see not just the files and directory that's listed here. You also see there's this hidden, in this case, it's a hidden folder. This is related to Jupyter Notebooks, and .git is related to the fact that we pulled these files from the GitHub repository. So the files that you're actually interacting with are, it's a copy of a Git repository, which is why this hidden file is here. Lis and -l will give me a more verbose description of the information about the files and folders that exist in the system. And I can combine the two by just typing them both together after the dash. So with the dash A and L, this will use the option for both listing all of the files as well as doing the long format for the files. So now in addition to the files, I have the hidden files, as well as the long format description. Let me just briefly mention what this long format description is. So there are a couple different parts to this. The first part, perhaps most obviously, is just the file name. So say here, I have this particular notebook, which I'm showing you, presented material.I, py, and b. This is just the file name, or the directory name if it's a directory. Next to it, we have the date. This is the last modification date for the files. So you can see most of the modification files, modification dates for these files and directories are the same. This is when I initially cloned the repository into this environment and the files initially got created. Next to that, we have this number. This number is the file size. So you can, this is in bytes. The notebook file is the largest file. The rest of these are not as large. Then we have two names that are listed together. One is Jovian. So I've mentioned that this is your username on the system. And then there's another name here, root. You don't have to necessarily worry about this column at the moment, but this is giving you information about the user who owns the file or directory, and then the group that's allowed to access it. So it's root at the moment because you're accessing a system that's a little more contained. If you access other Linux systems and you're part of other groups, you might find out about this more when you're part of other groups, but your group listing, the group that owns the file will be listed here in this column, the second one. The file here, or the number here, is the number of links to the particular file. I won't get into that, but that's just for your future reference. You might come across that sometime in the future. And then what's listed here is the file permissions, they're called. I'll talk about file permissions at the very end if I have time, but the basic idea is the first of these tells you whether it's a regular file, for example, which is denoted by the dash, or if it's a directory. And if it's a directory, it has a D here. So D for directory, this dash tells you it's just a regular file. And then you have a set of permissions. These are read, write, and execute permissions. And there are 3 sets of them. The first set is for the user, the second is for the group, and the third is for all users on the system. So we might come back to that a little bit later. But that's a description of all of the information that you see here listed. Something else which is useful for you to know is how to access information about the commands that you want to execute. So in our type, in the case of list, say, we can type list and then -- help. This is an example of giving an option to a command which has 2 dashes and then a full word after it. But if I type that, now this will give us, and I'm scrolling up here on the screen just with my trackpad because it's scrolling off the screen. Here's where I executed the command list help. The first thing it tells you is the usage. So it lists and then any options you give to it, and then any collection of files that you want to list information about. And then it tells you all of the options that you can use. So you can use quite a lot of options with the list command. It's probably not uncommon that you'll come across documentation which has say a lot of options for particular commands or a lot of information about what you can do with them. If we scroll here, for example, here is the -L. This tells us that it will use a long listing format. If I scroll back up to the top, the -A will tell us that it's not going to ignore entries starting with a period, which means that it will list all of the hidden files and directories in addition to all the regular ones. You can see here both a short name for the option and a long one. So if we wanted to type the long one, we could do ls-all instead of doing -A, just as an example. So help can be useful with any command. If we do the help for CD, I scroll back up to, let's see, here, CD help. This now has a little bit of a confusing syntax, but the basic idea is that what's in between brackets are possible options that you can give to CD. These are the options, and then you can optionally list the directory that you want to change into. So the basic idea is that you change the shell working directory. And it tells you also here the default directory that you change into is the value of the home shell variable. This is what I mentioned when I said, if you just type CD by itself and execute it, it changes into your home directory. So there's more here than I expect you to be familiar with at the moment, but this is a way that you can get more documentation about any commands that you want to interact with. So as a short little exercise, I'll give you, say, a minute here. Try ls with the option -lh. And then based on what you see, try to guess what it does by comparing it with ls and just -l. And then look at ls-help to check that that is actually the effect of this particular option. So I'll give you a minute here to do that. All right, let me try this myself. ls-lh. What's changed here is this. It still gives me the permissions, the number of links, username, group name, and then this is in a different format. It gives me the modification time and the name. So what this H does is it gives you the file size in human readable format. If I do ls-help again and I scroll up to look for H, here, human readable. So print sizes like 1K, kilobytes, megabytes, and gigabytes. Right. Okay. So now let's talk a little bit more about working with files and directories. I think some of the most important things that you probably want to do through the shell is to say copy files, move directories, rename things. Once you get proficient at it, you can be quite fast at this, much more fast than you interact with a more graphical user interface. So I'm just going to talk very briefly about ways to look at file contents. List tells me the files that are inside of here. And so I've included a file called animal data.txt. There are a couple different ways that I can look at the content of this file. One is to use the command cat. And if I do cat space animal underscore data.txt and hit enter, what this does is it prints the output of that. It prints the contents of the file to the output here on the screen. Cat basically comes from a short version of concatenate. So you could include multiple files here and it would successively print the contents of all of those to the output. Here, it's just relatively short that we can more clearly see what it is that we're looking at. More and less, you won't necessarily see the effects of those at the moment, but they have, so more it's going to look at like it does exactly the same thing, where it prints out the content. And less, less actually looks like it does something different. So it all of a sudden changes our screen. So there's no prompt here. It's just the contents of the file. And then the name of the file here in the end, and the blinking cursor. So what it's taken us into is a little bit of a different environment. Less is useful for looking at output, which might scroll across many, many screens. So it's like a paginator, where you can just look at the output across successive screens. To quit out of this, all I'm going to do is type Q. And then it returns me back to the prompt. I'll come back to more or less when we have something which actually scrolls across multiple pages. And then head and tail are also useful commands. Head is useful for looking at the top couple lines of a file, and tail is useful for looking at the last couple lines. So with head, you're given an option -n for the number of lines that you want to look at. Say I only want to look at the first two lines of animal data.txt, just to get an idea of what's inside of the file. I can do head -n2 and the name of the file, and that gives me the first two lines for deer and rabbit. If I do tail -n2, this gives me the last two lines. The last two lines for rabbit and deer on November 7th. So this is useful, if you have a file that has a lot of let's say text in it, and you only want to get an idea of what's in a certain part of the file, you can use head and tail just to get an idea of just a couple lines that are inside of it. I'm going to skip over this exercise thing here, but I think it's important to note that you now have enough information to interact with the command line interface so that you can navigate across the entire file system and try and look at the contents of any file that you come across. So say that I want to look at the different users which are on the system. I can change directory into, say the etc. directory. This directory is inside of the group directory. I can list the contents with ls. So now there are much more contents in this folder. And I can use cat, say, to print the contents of this file called passwd, which you don't have to worry about what this is exactly, but this is looking at a system file. A lot of the system files are text. If they're secret, you won't be allowed to look at them or to read them. So that read permission will be off for you. But a lot of the files that are in the operating system are free for you to peruse. Here's the Jovian user. And you don't have to worry about what this is, but this just tells you that Jovian is one of the users on the system. And then I'm going to cd back into my home directory just with cd. So I invite you to come back and just do a lot of looking around, just changing into different directories on the file system and looking at what the contents are. Because, to some extent, if you're approaching the command line interface for the first time, this is like moving to a completely different system and trying to drive yourself to the grocery store. You know, it might not be that difficult of a thing to do, but since you don't know the area, you know, the first couple of times that you do it, you might get lost or a little turned around before you find your way to the grocery store. Once you have lived in an area for a really long time, you get much more proficient at it, you know, and you might be able to drive to the grocery store blindfolded. So really taking the time to look around the system and get more proficient with the commands, I think will make this a much more intuitive process for you as far as interacting with the system. Okay. I'll change directories back into IDRI intro to shell. There are a number of ways to create and edit files strictly through the command line interface. Creating and editing files is often done with other programs, you know, so you might do a lot of this just through the graphical user interface if there is one. If you're interacting with a system just through the network and you have to create files inside of this command line interface, there are a couple purely text editors that you can use through the shell. Some of the common ones are VI, Nano, and Emacs. These are relatively spare text editors, but they do have a lot of power in that once you get proficient at the commands, you can really quickly and efficiently make changes to text files. So I'll just show you one here. You don't have to worry about what I'm doing, but VI animal text will open up the text editor. You know, I can change to a different place in the file relatively quickly. I can use kind of the cryptic command to change all of the occurrences of deer to moles, say, and that changes the two things. And then I'll save the file and exit out. So now inside of the file, deer has been replaced by mole in my case. This is just an illustration that once you get proficient at some of these text editors, you can do this relatively quickly. Particularly if you're coming at this from some kind of scripting perspective or administrative perspective, really getting familiar with these text editors can be very useful. And then I'll mention touch. Let me list along here. So touch, you can see that the images directory here and the file called README have an older modification time than animal data and presented material. I can use touch to change, let me change the modification time for README. So with touch now, README now will have a modification time, which is the current time. There are kind of a variety of reasons you might want to do this, but another interesting use of touch is that you can use touch to simply create an empty file. So if I put here touch space and then the name of a file that doesn't exist, let me come back over here. And well, I didn't have to refresh it, just popped up. So you see here now, empty file.txt has been created. If I try and look at the contents of it, there are no contents, it's just an empty file. But for various reasons, you might want to create you might just want to create files for programs to later interact with. And touch is a way to simply create an empty file. A couple things about names and extensions for file names. I've been including .txt here after text files. And for example, I have .ipynb here. If you have image files, say you have a JPEG, let me list the contents of the images folder. If I list the contents of the images folder, these are the contents, and you can see I have JPEG files, PNG files, I guess just those. As far as Linux is concerned, the file extension doesn't matter. I can have text files which don't have the TXT extension. I can have image files which aren't labeled with JPEG. I can even change this JPEG to TXT, and Linux won't necessarily care. However, applications that you use to interact with these files might care. That's particularly true, say, in a graphical user interface environment or for applications that you run through the GUI. So in some sense, it is important to keep this file suffix, but as far as the file system itself is concerned, you don't necessarily have to have the extension. Something else, well, I've mentioned about hidden files with the period in front. It's also important to know that Linux is case sensitive. So capital letters versus lowercase will make a difference to the file name and to the ability of the operating system to recognize what it is that you're talking about. You also have to be careful with spaces. So let's say that I create a file here with touch that's called, this file has spaces.txt. And I have to be a little bit careful about this, so I'll tell you why. When I list the contents of the directory, this file is listed here. And you'll see, so it now pops up. It recognizes that this is just a single file, not 4 different files, one for each of the names here, because they're separated by a space. Let me try this without the quote marks. It didn't give me an error. But what did happen? I miss this. So it did something which is kind of funny. It created separate files called this file as and spaces.txt. So the reason it's kind of funny to use spaces in file names on Linux is because when you're interacting with the command line interface, you use these spaces to separate arguments to a command and to separate options in some cases. So if you want this thing to be considered as just one entity by the command line interface, you have to enclose it by quote marks so it knows that this is just one thing. And it doesn't try and think that it's 4 different things that you're passing in as arguments to the command. And then a final thing here that I think it's important to know is wildcards. So wildcards are ways of trying to interact with multiple files or directories that have some commonality to the name in them. So I type list and it lists all of the contents of the directory. I can list only specific, say, files inside of this directory by passing in the name of the files that I want to list. So say I want to list animal data and presented material. This will only list these 2 files. So say now I want to list every file that starts with the capital T. You can use a wildcard to do this. So wildcards are useful for matching patterns. I know that I want the file name to start with the capital T. And then I can use this particular wildcard character here to match 1 or more occurrences of any character. So I can use T and the asterisk to match any file name that starts with the capital T and has 0 or more characters after it, which in this case is this, these 2 funny dummy files that I created. Say I want to be more specific. So I don't want just 0 or more characters after it. I know that this is kind of going to just be a dummy example, but say I know that I want a file name that is like this, where I know it starts with a T it has some character that I'm not sure of, and then it ends with IS. The question mark will match any single occurrence of that character. So in this case, it will only match this. It won't match both this and this file has spaces.txt. So asterisk for 0 or more characters and words of any length, and the question mark just for a single character. And then finally, you can include in here brackets. So say I think it has to be some vowel. I could say that I want to list all of the files that start with capital T that have one of these letters in the second space, and then I in the third and S in the fourth spot. So here there is no such file or directory. Well, if I type H, that's maybe obvious. Let me do a bunch more here. Right. I don't quite want to make this command because that's too complicated. So I'll just type these. It did a funny thing here where you don't have to worry about this, but this does illustrate something which you might want to know about, which is if you somehow inadvertently end up something which the shell thinks is a command to start something different and to expect more input from the user, you might see a caret appear here. And the prompt all of a sudden disappear and it just wait for you to put in input. And you'll see, for example, when I type the Q, it just gave me another caret. It can take me back to the prompt. So in order to escape from things like this, where you might end up in a situation where you aren't sure what to do, and all you know is you want to get back to the prompt and you want to quit the command that's running, you can type Control and C, and Control C will then exit out of that command and take you back to the prompt. So that's kind of a useful aside for if you run into that situation. Here, when I didn't type in the quote mark, and I just typed characters, now it listed the files inside of this directory that have any of these characters as the second character in the file name, of which this is the only one. So now here's the fun little exercise. I'll just let you think about this briefly. So say that we're in the molecules directory, and we have these two files, ethane.pdb and methane.pdb. Which of the command or commands here will say that we have a lot more files than just these two? Which of these commands will list these two file names as output when you execute them? I'll give you a minute here to think about that. Okay, so let's consider these one by one. This will list those file names that have 0 or more letters here before a T, and then 0 more letters in between the T and in between the aim.pdb. So that will match methane. That's fine. And it will match ethane as well. So this one is okay. This one, you can have anything after the any period, which satisfies both of these. You can have anything before the T, which is okay. But then you can have only one character between the T and the NE. Here there are 2, and here there are 2, so this one won't work. Here you can have two characters, not just one, but it has to be explicitly 2. So that will match the H and the A, and then you have the any.pdb for both of them, and then the E before the T here, and the ME before the T here. So this one is okay. And then ethane any number of things will not match with methane, so this one won't work. Okay. So let's talk about making directories and moving things and copying them. To make a directory, this is the command, mkdir, and then the name of the directory that you want to create. I'm going to, let's say I want to make a directory called my first directory. Mkdir is the command, and then this is the name of the directory that I want to create. You see it popped up here on my file list, my first directory, and it shows it with the folder. This is a directory now. And if I really want to check, I can do list and -l. When I look at my first directory, now it has the D here, which tells me it's a directory. Another thing, just to refresh your memory, is that I'm specifying the directory with the relative path. I'm using the up keys to go up, and I'm going to change this to my second directory. And I'm going to change how I specify it to the slash and the period. I'm sorry, the period and the slash. The period is the name from my current working directory. And then I include the slash because I want this directory to be a subdirectory of the directory I'm currently in. And when I execute that, now this is another way to create a directory inside of this, where this is another way to specify the relative path for the directory that I want to create. And if I want to really get long-winded, I can specify the entire home Jovian degree and my third directory. You can specify the absolute path as well. So my third directory will pop up here, and when it refreshes, yeah. So making directories is relatively simple then. And then I'm going to change directory into my first directory. All right. So if I list the contents, there isn't anything in the directory that I just created. Not at the moment, because I just created it. But let's say that I want to move this file called has, which is just a bogus file that I created with touch. I want to move it into the current directory. The command for move is mv. And then to mv, I have to give the path for the file that I want to move. And then following that, I have to give the path for where I want to move it to. So the name for the file that I want to move is has in the parent directory. the one that's in IDRI Intro to Shell CLI. So the shortcut for your parent directory is the ... And then I include the slash because it's something that's contained inside of that directory, inside of the parent directory. So the name of the file is has. This is the relative path for the file that I want to move. And then I want to move that into the current directory, which is the shortcut is period. Now, if I list the contents, has will be moved from the parent directory into this one. And you see, so it disappeared here from my file list. I could also have used the absolute path for any of these, for moving them. Say I wanted to move the file called this into the current directory. So the current directory is my first directory. This thing here is the name of the absolute path for the file this. And this thing here is the absolute path for the directory that I want to move it into. And you'll see here I didn't specify anything more than a location. I can explicitly say that I want to rename this when I'm moving it, just by giving it a different name. It's different. So now I can list the contents of the parent directory. This, which is what I moved, no longer exists. And inside of this directory, it's not called this, it's called this different. So if in the move you specify a different file name as part of this new file path, it will change the name of the file that you're moving. You do want to be a little bit careful now when you start moving and copying things, because Linux is not going to assume, that it has to take it easy on you. It's going to assume that you more or less know what you're doing. So if you decide that you want to move a file, let's say I move the other file called this. This file has spaces.txt. So what I'm going to use, rather than typing all of that out, I'm going to use the tab completion. And now I'm going to move it into the current directory, and I'm going to name it has. It's not going to complain about it. It's not going to try and create a has number 2. It's not. It's going to assume if I want to name it this, then I really know what I'm going to be doing. So it's taken that file and it's replaced has by the file that it moved into it. So to some extent, when you're moving files around, you do have to be careful that you know that there's the potential for you to overwrite something. There's an option that you can give to move to prompt you whether or not you really want to do something. So say I want to move animal data into the current directory and name that has. But say I'm automating this process and there's the potential that I could be doing something wrong. So if I'm automating this process and I want it to prompt me, I can give this flag called -i, which makes it interactive. And now when I try and move it, it's going to question me. It's going to say, do you really want to overwrite this file that actually exists? And I'm going to say no. So has still exists. And in my parent directory, animal data, it still exists. It hasn't moved it. So this is one way that you can kind of build in a little bit of a more safeguard into your move operations. I'll talk shortly about deleting files too, which is another useful place to add in the safeguard. Copy is similar to move, but it leaves the old file and simply creates the new file as a copy of the old file. So if I want to copy, let me try the same thing. Copy with a dash I interactive into has. So it's going to warn me again about overwriting. And this time I'm going to say yes. All right, so now I have a file called has, which existed before. And in the parent directory, I have this file animal data. Let me look at the contents. This is in the animal data that exists in the parent directory. And if I cat the file that's now called has, it's the same content. So I've copied the old file over on top of the new one. You can also copy directories. I'm going to change into the parent directory with cd and ... for parent. So images is a directory. And say I want to copy images into my second directory. There are a couple ways to kind of carry this out. Let's say I do something like this. It's going to complain because copy is good for files. And if I haven't specified an entire list of files here, it doesn't really know how to interpret what I've done. One thing to do if you want to copy an entire directory into another directory is you can include the -r, and this flag is for a recursive copy. So if I include the -r, what's in my current directory images still exists. All I've done is copy it. And then if I list the contents of my second directory, images also exists in it. And if I look further at images, the images have also been copied in there. So the -r is useful for recursively copying a folder. It copies the directory itself as well as any subdirectories and files within all of those subdirectories. It copies it kind of as an entire file object thing into wherever it is that you're trying to move it. And let me talk here finally about remove. So if you want to delete a file, rm is the name of, is the command. And then you specify either the absolute or the relative path. So say I change directories into my second directory where I've copied in the images. And I realized, well, that's a dumb thing. I don't want the images directory in both places. So I can remove images. It's going to tell me that it doesn't want to do this again. So it's something similar to like the copy. It might be that I've specified the directory name, but don't really want to delete everything inside of the directory. So I have to explicitly tell it to recursively remove everything that's this directory name and anything recursively inside of it. The -r then is useful for deleting directories. But again, just like with the move, you do have to be careful because there's no trash bin in Linux for you to retrieve deleted things from. So there's this -i flag again where you can make things interactive. I'm just going to quickly copy in the images folder again here. So the images exist again. And if I do both the recursive and the interactive, I'm going to say yes to send them to the directory. And then I can pick and choose which of these files I want to delete. I'm going to delete the Linux. No to all these. And since I absentmindedly specified yes for the last one, it complains that it can't do that because the directory is not empty. So just as a strong word of caution, actually, be very careful with remove, especially if you use wildcards. So say I go into images and I see that there are PNG files, JPEGs, So say I want to use a wildcard to remove everything that has the JPEG suffix to it. Well, I can do that, that's fine. So now it's deleted, or it's removed all of those files that have .jpg. And it's left the PNG files and the ones that have the JPEG suffix. Say I now decide I want to remove the PNG files, but I absentmindedly include a space here. So what's this going to remove? Oops, remove. It's going to think that I want to remove everything in addition to a file that's called .png. So the first thing it's going to do is it's going to remove everything. And then it's going to tell me that .png doesn't exist. But if I list the contents, it's deleted everything. So you do have to be careful about using wildcards when you use remove. Because if you mistype something, or if something gets interpreted incorrectly by the shell, you can quickly do a lot of damage to the files that you have. Yeah. So let's see. We're coming up. There's some stuff to read down here about IO redirection, which I won't get into at the moment. But just as a couple final exercises, let's consider the following. So this is kind of to wrap everything up. Say I've moved some raw data files into the wrong directory. So say I started in this directory called shell course. And when I list the contents, it has analyze data and raw data, which are two directories. And then I list the contents of one directory, it doesn't have anything, doesn't produce any output. And I list the contents of analyze data, and it produces these three file names here. So I change directories into raw data, which doesn't have anything. The thing to consider now is what command can I use to move all three files into the analyze data folder? And to try and do it in at least two different ways. So since we're at the end of the class here, I'll just give you, I'll just tell you what I would do. So let me go into my third directory. So I'm going to make analyze data and raw data. And I'm going to create file1.dat, 2.dat, and hopefully you're starting to understand the commands that I'm going through, even if it is a little fast. So now when I list the directory, it has the two directories. If I list raw data, it doesn't have anything. And if I list analyze data, it has the three files. And then if I go into raw data, it doesn't have any content. One way to move all the files is to use the move command. This is the notation for the parent directory. Inside the parent directory is the analyze data folder, which has the files that I want to move. I want to move everything to the current directory. So now the three files are here and nothing's inside of file. I could have done that a different way. So say I want to move them back. I can specify the absolute path rather than just the relative path. Degree intro, my third directory, and raw data, all of the files. They're file number .dat. So I can do 1, 2, or 3 .dat into the current directory, which moves them all back. And then there's an additional exercise here, which I invite you to look over later. I think I'm just going to take questions just so you know the IO redirection is a way to send the output of a command to a file. And then I have pipelines will allow you to join different commands together. And then another thing that you definitely probably want to read up just a little bit about is how you specify permissions for files. But at the bottom of this notebook, I've included a link to a book which I think is really excellent, and it's available for free as a PDF download if you want. If you want to read more about interacting with Linux command, as well as much more about what I showed you, this can be a really interesting read. So I'm going to stop here, and I'm going to stop the recording and ask if people have questions.